Hey guys, this is MathHeads 101, and in this video I'm going to be deriving the rotation matrix formula. So, for this derivation, first let's understand what it does, and then let's go. Okay, so the rotation matrix formula, basically you have some vector, okay, and if you rotate it by theta, it's going to give you a new vector, okay, where you literally take it, you take this vector and you move it theta across, okay? So, how does this work? Okay, well, first thing we're going to do is define a vector. So I'm going to say vector v equals a, b, okay? So, I'll make those capital. Okay, vector v equals a, b. Okay, so what that means is if you have your coordinate axis, this is your vector. So this is a distance of a from the origin in the I direction, and this is a distance of b from the origin in the j direction, and that's how you get your vector. Now, so the vector that's perpendicular to this, I'll say vector u. That, and u, I'm going to say u is perpendicular to v. Okay? And vector u is equal to b negative a. Okay? So how do we get that? Well, if you make a vector that's perpendicular to this, so we're going to take this and rotate it. We're going to rotate it pi over 2. We're going to rotate it 90 degrees that way. Okay? So it's going to look like that. And this is a right angle. And so since we rotated it, A is that height for this guy. Maybe that's A. So, and B is that guy. Okay? So actually, wait though. So this is, so basically, you're taking, it's going to be, so the x is going to be negative, and the x is the I direction. So it's going to be a negative b and a positive a, right? Because we're taking this, and if we rotate it, then this we could see is going this way, and that we could see as going that way, right? So it's minus b and then a, okay? So now, if we take the rotation matrix, which we don't know what it is, but we know it's going to be a 2 by 2 matrix because you're multiplying it by a vector with a two-dimensional vector. So we're just going to say some matrix, A, B, C, D. These are our numbers in the matrix. We're going to multiply that by AB, and we want our result to be minus B, A. Also, another way to think about this is the slope of the normal line when you take something perpendicular, because if you take a slope and you want a perpendicular slope, okay, so this was a negative slope, so it's going to be a positive slope, and if this one is very steep, then the other one's not steep at all. So it's the negative reciprocal. So here we have the reciprocal, and it's negative, and we know that that one's the negative value, not that one, because we're rotating it clockwise. Okay, so how do we do this matrix multiplication? Well, we do the rows in here times the columns in here. So we're going to do A times A, or little case. Alright, A times little a plus B times little b is going to give you that one. So that's equal to negative b. And we also know, okay, so then we do this column, this row times this column. So it's A times C plus B times C, no, B times D, my bad, is equal to A. Okay? So how do we figure out what A, B, C, and D are? Okay, well this guy we don't want any B's here, right? Because this has no B's in it, and we don't want any A's here. So if this is 0, we need this term to be 0 to cancel out all the A's. So A has to be 0, but let's see if that affects that. It doesn't, because there's no lowercase a's in here. So we know lowercase a is equal to 0. Lowercase a is equal to 0. So that thing, so I'm going to put that there. A, B, C, D is equal to, so lowercase a is equal to 0. Okay, well if this is equal to 0, how do we get minus b? Well, that means lowercase b has to be minus 1. Okay, and does that affect this? No, so it works. So this is minus 1, because lowercase b equals minus 1. Okay, then c, well we only want a's, and we don't want to modify the a. So this has to be 1, and that has to be 0, and that doesn't affect that. So we know that c equals 1, and d equals 0. So then we have 1, 0. Okay? So now that we know that, we know what our rotation matrix is to rotate around the circle pi over 2 radians or 90 degrees. So literally what we did, here's our unit thing, our unit circle. Okay? So this is pi, this is 0, and okay. So we're dealing with this, okay? We're dealing with pi over 2. Okay, that's how much we rotated our vector by. Okay? So we rotated our vector, so we can only use a theta of pi over 2 to get these. So if we have pi over 2, so this, okay? So what about this is going to be 0? Well, its y component, well, its x component is 0. It has no x part. So that's just going to be cosine of theta. So we also know that that is equal to this guy, 0, that's cosine of theta. So I'm going to actually write it twice, because we already figured it out. So this is cosine of theta, and this is cosine of theta. Now how can we get a minus 1? Well, if we're dealing with this, so the y component would be 1, but the negative y component, so minus sine of theta is going to be minus 1, which means that sine of theta is 1. So now we derived Q, E, D. Okay? The rotation matrix is equal to that, which it makes sense, because obviously it's going to be in terms of trig functions, and yeah, and another thing to think about is what happens when you multiply the rotation matrix by itself. So for example, if you have a rotation matrix where theta is equal to pi over 2, like we just had, so first you would have this vector, and then you could move that, it would be this vector, and then you do it again, so you're squaring the rotation matrix, and you're getting that. And this is actually negative that, okay? So the eigenvalue of the rotation matrix there is going to be negative 1, because you're just taking your vector, and you can think about it as multiplying your vector by negative 1. And another cool thing is if you go all the way around, so if you take your rotation matrix and bring it to the 4th power, you're really, because no, really what I'm saying is AX equals lambda x. What's the lambda? Okay, well we'll say AX equals mu x, where I'm using mu instead of lambda because I forget what the lambda symbol looks like. So A is the rotation matrix, so this is the eigenvalue. So what vector is going to be, what vector can we get when we, if we square the rotation matrix of rotating a quarter of the way around, then it's like the eigenvalue. If we go halfway around the circle, you're taking the negative, so the eigenvalue is negative 1. And if you go all the way around the circle, you just did nothing, so the eigenvalue is just 1. So a cool thing to think about is the eigenvalues of the rotation matrix. I hope that helped. Thanks for watching.